All right, guys. So this is the final type that we are learning on the exercise 5A. Okay, so on the exercise 5A. So this is the final type of the theory that you need to learn. So we are going to learn about. So this is the fifth one that we are discussing, right? The fifth type of topic. This one, we are going to find the center of mass of a uniform wire in the form of an arc of a circle. Can you guys see? So the in the fourth type we learned it was the center of mass of a uniform lamina in the form of an arc of a circle. So you know the difference between the wire and the lamina, right? So in the wire you only have this curved part. So this is the wire. Can you guys see? So the one I'm highlighting in blue. So this is the wire. That's it. You just have the wires. There's nothing inside here. So it's you just have the wire. All right, guys. So I think again, this is something that you have done in M2, right? The equation. You have learned already how to use the equation in M2. So now we are going to learn in M3 how the equation is derived. Okay, so this is the wire. All right, guys. So radius is R. So basically, most of the terminologies are exactly the same as we did for the arc, for the lamina, for the circular lamina. Basically, you can see here once again the way we divide the strips is exactly the same. Can you guys see? It's exactly the same because we divide the strips by using the angle theta. All right, guys. So let me mark the full angle here is alpha. Okay, so now you know what you should do. So you should get the mass of one strip and the center of mass of one strip. All right, guys. Okay, so let's get the mass of area of PQ. Sorry, guys. How do we get the area? How do we get the mass? Are we going to go for the area now? So when you're taking this, guys, you need to be really cautious now because we are taking a wire. So there is absolutely no area inside, right, guys? This is an empty space. It's a wire and this is an empty space. Are you guys with me? This is a wire. I'm trying to make it 3D just so that you can see it's a wire. All right, guys. So there's nothing inside here. You just have this wire. All right, guys. So in that case, you need to be really cautious because you over here, you are actually what? Dividing. Let me try to draw this one. All right, guys. So this is the wire. I just wanted to show some thickness onto it. Guys, there's no area here. I hope you understand that. So this time, what is going to contribute to the mass? So when you divide this into strips, what are you dividing? I hope you guys can see that it is this length that we are dividing, not the area. We are dividing this length into so many strips. Can you guys see? It's the length that's dividing. The length of the wire is what we are breaking into strips now. All right, guys. So basically, in this case, in the case of a wire, it's the length of the wire that's going to contribute to the mass. It's the length, not the area. So that's really important. So how do you get the length? So get the length of the PQ wire of the section PQ. So length of a sector. What's the equation to get the arc length? So you have learned in P1, the arc length is given by R theta, right? Arc length is given by R theta. So in this case, R theta is delta theta. Guys, can you see? So R into delta theta. And then to make it mass of the sector PQ. So it's R delta theta into rho. So in this case, rho is going to be what? Rho is going to be mass per unit length, not mass per unit area. In this case, rho is mass per unit length because we are working with length now, not with area. All right, guys. So these are some important things. So mass of PQ is R delta theta, that is the length of the arc multiplied by rho, that gives you the mass. All right, guys. So that's done. Now let's go for the center of mass. All right. So what about the center of mass? Center of mass of a wire piece, right? So is it going to be in the middle? Like now, theories are going to change now completely. Can you use the middle of the wire and use G as we did before? So previously we used G in the middle of the lamina, but now we don't have a lamina, right, guys? So you need to understand that where is the center of mass of this small part going to be? So this is the strip that we are considering, right? So this PQ strip. Can you guys see? So where is the center of mass of this strip? The center of mass of that strip should be exactly in its middle, right? Guys, can you see the center of mass of this should be exactly in its middle, right? Right, guys? So how do I get that coordinate? So guys, I think you can see here O to G, this length. You know G is at the edge of the arc here, right? It's in the middle of the PQ wire. So basically, your center of mass is going to be exactly on the radius, right? You don't need a 2 to 1 ratio now because you're not, the center of mass is not somewhere in the middle. The middle is completely empty. There's nothing inside. There's no lamina. There's no mass here. So all your mass is concentrated on the wire. So if you're taking the PQ wire, the center of mass of the PQ part of the wire should be in the middle of the PQ wire. Do you agree? The center of mass of the PQ wire should be in the middle of PQ wire. So it's not somewhere in between. All right, guys. So this length is OG length is R, and I hope you guys can understand. So I told you this angle, the full angle is theta plus delta theta over 2, right? Because you divide this into 2. So you can see we take half of delta theta, but I told you delta theta is extremely small. So this is equivalent to theta, right? Because delta theta is small when you and divide by 2 becomes even smaller. At theta, it's negligible. So it becomes theta. So guys, the center of mass coordinate is going to be OG cos theta, right guys? Because you need to get the x coordinate, right? We need the x coordinate. I need this distance. I need the x distance. Right guys? So it's OG cos theta. And we know OG is R. So it's basically R cos theta. So this is the important thing. So that's it. If you are able to get this stuff, you know the rest of the thing is really easy. All you have to do is to put this into the equation. However, over here, I want to do one more change for the total mass, sigma mi. Okay, the total mass, I really don't want to, I told you, if you know the full thing, you really don't need to use integration to find the total mass. Now over here, the total mass is what? We don't have area. Be careful here. So in here, the total mass is the total length, right, guys? The total mass is the total length times rho. In the previous case, the total mass was the total area times rho. Now it's total length times rho. So what's the total length? If you take this sector, I think you can see we can easily get the full length, right? Because we know how to get the length of a arc length of a sector. Arc length of a sector is r theta. So r, what's r theta here? R theta is 2 alpha. Right guys, r theta is 2 alpha. So r theta into rho. So you get 2r alpha rho. Guys, can you see? So for sigma mi, instead of going through the integration, taking the mass of one strip and taking the sigma and, going through integration, we can go through with this and that's going to, reduce the work for us. That's going to reduce the work for us. So this is all you need. So we have everything we require now. So just apply to the equation sigma mi xi equals total mass into x bar. Total mass, I just put capital M for total mass. That's the sigma mi, right guys? Sigma mi is the capital M here. Okay. So that reduces one integration aspect. You could have done this exact same thing for the previous part as well. If you recall in the previous part for the center of mass of the uniform sector where it was a lamina. I think you saw in the lamina we used the area. So for the center of mass, I could have used the total area and instead of going through this integration, I could have used this value here. All right, guys. So that was in the previous video. All right. So over here, I'm actually going to use the shortcut instead of going through the long method. All right. So let's apply the values and quickly get the answer. So we have here sigma mass is R delta theta rho, that's the mass of one strip, multiplied by center of mass is R cos theta. Equals total mass is 2R alpha rho into x bar. All right, guys. So now let's integrate. So as delta x goes to 0, the summation becomes integral. So you have here R into R square. Rho, you can take it out, R square. Cos theta, delta theta becomes d theta. On the other side, 2r alpha rho x bar. So cut off the rho value. And what about your integration limit? So we know by now the wire starts at minus alpha and ends at plus alpha, right guys? So here it's minus alpha to plus alpha because we mark the x-axis as theta 0. All right, so below theta 0 it's negative, above it's positive. So your integration limits are from minus alpha to plus alpha. And then I think you can even take the r square out of the integral sign. Integration is with respect to theta, so r square can come out. minus alpha to plus alpha. Over here you have 2r alpha x bar, right guys? So we'll apply now. The cost integration is sine theta, right guys? Minus alpha to plus alpha 2r alpha x bar. All right, so let's apply. So sine it's gonna be sine alpha minus sine minus alpha, right? Two r alpha x bar. R square sine alpha minus minus is plus, right? So you get here 2 sine alpha. 2r alpha x bar. So we can cut off the 2. We can cut off 1 r. And I get here r sine alpha over alpha, right guys? Right, guys. So, yeah, it's r sine alpha over alpha, and that's the answer once again. So, this is something a result that you have already used in N2, but now you also know how to derive this result using integration. Right, guys? So, this is it, r sine alpha over alpha. And what about y bar? Do we need to find y bar? No, as you can clearly see, the wire, we are placing it on a line of symmetry along the x-axis. So clearly, your y bar is 0. The center of mass of the complete wire, y bar is 0. Right, guys? So basically, only one x bar needs to be specially found. Right, guys? So I hope this proof is clear with everyone.